Yes, so in some ways there'll be similarities in requirements. Some of the infrastructure will be the same; they'll be required, but then there'll be some special ways that need to be integrated. Let's start with the simple first, the infrastructure. So of course you've got to have space for your QPU. I don't think that's going to be an issue in the beginning. I've been inside these supercompute facilities; they are huge, and so having an area for a number of QPUs in the beginning, let's say 4 to 10, is really not going to be a challenge as long as they're planned for. They need power, they need cooling, and so their cooling is colder than the cooling water used for the classical computers. So you'll need to have tap into that power and have, of course, liquid helium and heat and hydrogen to cool. So there'll be some new requirements around the chemicals that are required, but the space, I think, shouldn't be an issue in the beginning as these first demonstrations are done. Really where it's going to have unique requirements is really in the networking and connecting the quantum computers into the classical fabric through switches. The good news is that as long as you're networking in the optical domain, you can actually use some of the same switches to do the routing. Aliro has an optical network in our lab, and we're actually using a Dicon switch to transmit the classical data as well as do the entanglement. So you'll have some commonality, you'll need some different devices, but you'll importantly want to design the layout of the supercompute facilities so it's in the right place, it has the necessary power, and that it can be networked in, and then jobs can be assigned and run. So I think some of the most tricky work will be actually in the software of how you're going to take the jobs from users and have an algorithm that's going to run some of the jobs on the classical resources and some on the quantum. So I think that's where the power of the software to solve that complexity is going to be really seen.